Hello, in this video we're going to look at mathematics for business and economics, talking about geometric series. So our first application is going to be with the multiplier. So for example, let's say the government buys $1 of military hardware. So the government spends $1 on military hardware. There's going to be this so-called multiplier effect. This $1 of military spending will increase the income of the defense industry by $1. Okay, so that's change in income. The defense industry sees their income go up by $1 right here. Because the marginal propensity to consume, the MPC, is 0.9, the people in the defense industry will spend 90 cents of their new income on things like food and clothing. Okay, so that spending on food and clothing becomes new income for people in the food and clothing industry. Because the marginal propensity to consume is 0.9, the people in the food and clothing industry will spend 0.9 times 0.9 or 81 cents on other things, entertainment and so on. And that 81 cents or 0.9 times 0.9 becomes new income in some other industry, and this whole process repeats. When all is said and done, this $1 of spending will change income or real GDP by $10. So how can we find this 10? Well, what we want to do here is find the sum of all the spending. So let S equal the sum of all spending. And in this column here, you'll notice basically we have a sum of a geometric series. You've got 1 plus 0.9 plus 0.9 squared plus 0.9 cubed plus 0.9 to the fourth and so on. So what will that sum to? So let's do a substitution. We're going to let L equal 0.9. So wherever I have a 0.9, I'm going to put in an L. So in this case, 1 plus L, 0.9 squared is just L squared, 0.9 cubed. Since L is 0.9, it's L cubed. I want to create another equation now, call it LS, which is just L times S. So we have this S equation. I want to multiply everything through here by L. So 1 times L is L. L times L is L squared. L times L is L cubed, and so on. So now we got two equations, an S and an LS equation. So here's the trick now. We're going to take our S equation and we're going to subtract from it our LS equation. So here's our S equation right here. And then we're going to subtract from it our LS equation. And what is nice is pretty much everything cancels. L minus L cancels. L squared minus L squared cancels. L cubed minus L cubed cancels, although I'm not showing it. L to the fourth minus L to the fourth cancels, and so on. The only thing we can't cancel is this 1. There's no minus 1 over here. So simplifying then, S minus LS equals 1. And now let's factor the left-hand side. So factoring an S term out on the left-hand side, we get this result. And now let's divide through by 1 minus L. So S equals 1 divided by 1 minus L. What is L? The marginal propensity to consume, or 0.9. So doing the math here, 1 minus 0.9 is just 0.1. 1 divided by 0.1 is 10. So that is the multiplier effect. $1 of government spending, when the MPC is 0.9, increases real GDP or income by 10 times that, or $10. Let's do another example. Example 2. What is the present value of receiving $1 at the end of each of the next 20 years? So if we're to write this out, 1 divided by 1 plus R, where R is the discount rate or interest rate. So that's at the end of the first year, at the end of the second year. The value of that $1 receiving at the end of 2 years is given by this equation, and so on, all the way up to the 20th year. So what would this equal? Well, let's do a substitution. Let L equal 1 divided by 1 plus the interest rate or discount rate. So in this case, the present value equals L plus L squared plus L cubed, so on, all the way up to L to the 20th power. So let's create another equation, L times PV. We saw this in the first example. We have this PV equation. Now I'm just going to multiply it through by L. So L times L is L squared. L squared times L is L cubed. All the way up to L to the 20th times L is L to raised to the 21st power. So we have our PV and LPV equation that we showed on the other slide. And so as before, let's take the present value and minus it by L times the present value. And once again, a lot of things will cancel. L squared minus L squared cancels. L cubed minus L cubed cancels. L to the 20th minus L to the 20th cancels. The only thing that doesn't cancel is this L, and this L raised to the 21st power. So simplifying the right-hand side, we have this. On the left-hand side, let's factor out the PV, and then divide through by 1 minus L. So we get this expression for the present value. Once again, just rewriting that result. And now where I have L, I'm going to put in 1 divided by 1 plus the discount rate or interest rate. And we get this result. And let's just mathematically simplify it a little bit. Let's get a common denominator down here in the denominator. So we're going to add these two terms up down here. So doing that, we get this result here. And then just going to add up these numerators on. The 1 minus 1 cancel and just have R up here. So you get this result. And the next step I want to do is I want to take what's in the denominator here and multiply the denominator and numerator by its reciprocal. So R divided by 1 plus R, we're going to multiply that by its reciprocal. And since we're doing that in the denominator, we have to do that to the numerator. So there's the 1 plus R divided by R over here, and then we've got to do it to this term over here, 1 plus R divided by R. So let's simplify this then. This denominator is just 1. This 1 plus R over here cancels with this 1 plus R over here, so you just have 1 over R. And then over here, this 1 plus R divided by 1 plus R raised to the 21st power is just 1 plus R raised to the 20th power. And then we have this R hanging around. And if we wanted to, let's put in a discount rate of 10% and evaluate the formula. And if you do that, we get $8.51. One thing to note here that if this, instead of receiving $1 each year for the next 20 years, it was 100 years or 1,000 years, or it was for infinity, a perpetuity, this term rate over here basically goes to 0. Okay, so as the time periods increase, this term over here basically goes to 0, and you get basically 1 over the discount rate, which is the perpetuity formula, receiving $1 at the end of each year from now until eternity. All right, that's it. I hope you found this video helpful.